Welcome to This Explainer. Today, we're unpacking the massive, fascinating global effort that's propelling humanity right back to the lunar surface. You know, for thousands of years, the moon has guided explorers and inspired our myths. But today, it's not just a symbol in the night sky anymore. It's literally the center of one of the most ambitious international competitions in human history. So, let's just dive right in with the most obvious question. After 50 years away, why is the world suddenly racing back to our closest celestial neighbor? For a long time, a lot of us figured our greatest lunar achievements were stuck in the past. But wow, that assumption has changed completely. The race we're seeing today is fundamentally different from the one we watched back in the 20th century. To figure out why, here's our roadmap for today. We'll look at the new space race, the global competitors, the lunar space economy, surviving the lunar surface, and finally, our next stop, Mars. All right, let's jump right into Section 1, the new space race. The stark contrast between these two eras is pretty mind-blowing. The Apollo program was an absolute engineering miracle of the Cold War, but it was really about brief, government-driven visits focused on planting flags and leaving footprints. But this modern era, it's a completely different beast. We're talking about a global coalition backed by huge commercial partnerships, all aimed at a permanent, continuous presence. This time around, we aren't just visiting, we are staying. To really understand how we got here, we have to jump back to 1972. Ever since those final Apollo astronauts left the lunar surface, the moon has just sat there, untouched by humans. And it wasn't that we just lost interest. It was really about changing financial priorities and a pivot toward long-duration missions in Earth orbit, like the International Space Station. Plus, let's be real, the tech of the 70s just wasn't optimized for building a permanent settlement. I mean, the smartphone sitting in your pocket right now has millions of times more memory than the entire Apollo guidance computer. Which brings us to Section 2, the global competitors. You see, today's race is definitely no longer a two-player game. China's lunar program has rapidly ascended using this incredibly methodical, phased strategy. Every single step just builds right on top of the last one, from their first orbiter back in 2007 to their first soft landing in 2013. And then, in 2019, they pulled off something unprecedented, a historic soft landing on the moon's far side, which means they had to overcome some massive communication hurdles. By 2020, they were successfully returning lunar samples to Earth. They are steadily, methodically laying the groundwork for a long-term lunar presence. And then we have India's space agency, proving that you absolutely do not need the biggest budget to make history. In 2008, their orbiter actually helped discover evidence of water. In 2019, they definitely faced a setback when their lander crashed, but they learned from it so fast. Fast forward to 2023, and India achieves this massive milestone, becoming the very first nation to successfully land a spacecraft near the scientifically crucial lunar South Pole. Meanwhile, the United States is leading this massive collaborative push through NASA's Artemis program. Using the insanely powerful space launch system, NASA is sharing its expertise with agencies all over the world. The European Space Agency is providing crucial service modules and researching 3D habitat printing. Japan's JAXA is working on precision landing tech and these really cool pressurized rovers. And Russia's Roscosmos? They're partnering with China on an international research station. Together, these partners are building shared infrastructure, like the Lunar Gateway, an actual space station that's going to orbit the moon as a staging point. All right, moving on to Section 3, the lunar space economy. So all this global effort, it absolutely requires a sustainable financial model. We simply cannot afford to launch every single drop of water and piece of steel all the way from Earth. To put the economics into perspective, it costs roughly $10,000 to send just a single pound of payload into space. That brings us to a massive key in this new economy: ISRU, or in situ resource utilization. That's just the fancy scientific term for living off the land. By extracting and processing local resources right there on the moon, we drastically slash the astronomical costs of deep space exploration. Because, contrary to popular belief, the moon is far from just a barren rock. Finding frozen water ice in permanently shadowed craters, that is an absolute game changer. It gives us drinking water, breathable oxygen, and best of all, it can be split into hydrogen and oxygen to actually create rocket fuel. Meanwhile, the dusty lunar regolith itself can be processed and literally 3D printed into habitats and radiation shields. And we even have resources like helium-3, which gets deposited by solar winds and holds some really exciting theoretical potential for future nuclear fusion research. Now, this entire resource economy is really only possible because of a total revolution in commercial spaceflight. Private companies have brought us reusable rockets, which has significantly lowered the barrier to entry. We're transitioning away from the days of government-only projects and into a thriving commercial ecosystem. Private industry is out there building robotic landers, cargo vehicles, and communication networks right alongside national space agencies. Let's head into Section 4, Surviving the Lunar Surface. Because finding resources is great, but the moon is, without exaggeration, one of the most hostile environments imaginable. I mean, without a protective atmosphere, temperatures swing wildly. We're talking a boiling 120 degrees Celsius during the day, plummeting to a freezing negative 170 degrees at night. Astronauts have to deal with extreme cosmic radiation, constant micrometeorite strikes, and this incredibly abrasive, clingy regolith dust that just wreaks havoc on machinery and spacesuits. Literally every single aspect of life support has to be artificially engineered. To survive these downright deadly conditions, we can't just drop astronauts onto the surface and hope for the best, right? We're going to follow a highly structured construction plan. First, autonomous robotic scouts will arrive to prepare the landing zones. Then, robotic 3D printers will get to work constructing regolith, radiation shields, and basic infrastructure. Only after all that groundwork is completely laid by AI and robots will humans actually arrive to occupy the established bases. And where exactly will those bases be? Well, to survive the lack of an atmosphere and magnetic field, engineers are planning to literally dig in. Permanent lunar bases will likely be built entirely underground inside ancient volcanic lava tubes, or they'll be covered by several meters of that 3D printed lunar dust to create a physical barrier against radiation and micrometeorites. And to keep the lights and heat on through the long, freezing lunar night, these bases are going to rely on a mix of massive solar rays and compact nuclear fission reactors. And that brings us to Section 5. Next stop, Mars. The sheer scale of the challenge we face when we look past the moon is enormous. A lunar mission, that takes just a few days. If a critical emergency happens, a quick return to Earth is totally possible. But Mars? Wow. Mars is a 6 to 9 month journey each way. The total mission duration is 2 to 3 years. There is absolutely no immediate emergency help coming from Earth. A Mars mission demands total, absolute autonomy. And that is exactly why the moon serves as the perfect nearby proving ground. Before we take that monumental leap to the red planet, we have got to master closed-loop life support systems, where literally nothing is wasted. We have to prove we can actually manufacture rocket fuel from local ice. We need to develop autonomous robotic workforces. And we have to deeply study how the human body adapts medically to prolonged periods in low gravity. The moon is literally where we practice for Mars. It really all boils down to this core truth. The moon is simply the next frontier. It's becoming humanity's first real testing ground for living beyond Earth. Our return to the moon is no longer just a competition for national prestige like it was 50 years ago. It is a collaborative, absolutely necessary step in humanity's evolution into a true spacefaring civilization. Which leaves us with this final thought. As this new space economy blossoms, as these international partnerships form, and as the rockets roar skyward once again, we really have to ask ourselves, as humanity takes its first steps toward becoming an interplanetary species, who will build the vision to get us there? And how will mastering the moon fundamentally change our destiny back here on Earth?